Hello, we are from Crop Recommendation, and my name is Napunde Pasal.
My name is Santon Kamita. For our project overview, the crop recommendation system is an IoT and AI based solution created to assist farmers in selecting the most suitable crops based on their environmental and conditions. The system continuously gathers real time data from sensor and external API to monitor surrounding environment. For the crop prediction, users manually input the key values like temperature, humidity, and soil moisture, which are then processed by our machine learning model. Then recommended crops are returned through a RESTful API. The main motivation behind the system is to help farmers to choose crops that are grow better, leading to higher yields and less waste of resources like water or fertilizer or something. For our data sources, our primary data are collected from three sensors, which collected the value of temperature, humidity, and soil moisture. And for the secondary data, we're collected from Open Weather API, which provided value of temperature, soil moisture, which we use it for predicted the moisture later on. And the last one is Kaggle crop suitability dataset, which provide historical data on crop environment relationships, which we use for predicted our crop recommendation. Okay, let's move on to our overview of architecture. It starts with our sensor modules connected to KitBright. Then the data is flowed through Node-RED, which help in visualizing and forwarding the data to our MySQL database hosted on my PHP MyAdmin. And from there, the go back and we just take the data and process and store it and serve it via API. We also send the user input data to our machine learning layer, which is built in Fast API and use pre-trained model with joblib. Finally, the output displayed through React frontend. Yeah, that's our architecture.
This is our database schema. On the left one, we contain the data from the sensor, which is the sensor table, and it contains like ID, timestamp, and also temperature, humidity, and soil moisture. And the right one, we collecting from it from the API, which is contain the better information like the temperature, humidity, and wind speed, and better description, and also the place that we collect based on the latitude and longitude. And when we merge them, we will get this. And this is how we collecting the data. We use the sensor to connect to the KitBright, and then we use Node-RED to transfer the data into the database, which is the PHP MyAdmin. And on the Open Weather API, we do the same. We using Node-RED to transfer the data also, and we collecting the data around every 10 minutes. And this is our API endpoint, which is allow the external application to access the data that we contain in the database, and we will demo it later.
For our data visualization, we use line charts to show how temperature, humidity, and soil moisture change over time. This visualization helps users spot trends and patterns like when the soil tends to dry out or how temperature shifts during the day. By looking at this history, user can make smarter decisions like when to water or which crops to plant. User can also select a date range which make it easier to focus on specific time periods. This kind of insight is especially helpful in farming, where keeping track of environmental changes is key to planning and using resources wisely. And let's move on to our demonstration of key features. Let's start from the first page where we display the latest data from the sensors here and the average conditions for all of the value we have, and the recent data trends where we display the latest 2 hours and see. For the next pages, we had is historical data where we could select the range for line graph to be displayed. We could choose the 7 days and the average value for selecting period will be changed. Yeah, here the last 30 days is will be here. We could also custom our ranges by this. You can see it change accordingly. For the last 30 days, we can just drag this down and we can see whole time frames. Yeah. Most of my component is used by ChatCN, and for the line charts I'm using the recharts. Let's move to the location weather.
So on the part of location weather, I will show the example that how it used. So you need to provide the latitude and longitude that you want, or you can use the button, use my location. See, it will fill in with the latitude and longitude that you place, and you can use the get weather, and it will show you that the weather description and also the temperature and feel like the Celsius and humidity percent and also the pressure. And on the next feature, under prediction, you need to fill in the temperature and humidity, and it will show the predicted the moisture. And under crop prediction, it works the same, but you need to give the moisture. See, it will give you the recommended crop. And the statistic part, the web app, our web app will provide you guys the sensor statistic and their weather API statistic. But sensor statistic will provide you the temperature, humidity, and soil moisture, and they show the average, min, max. And the weather API statistic will provide you the temperature, humidity, and wind speed. So that's all. Swagger, which is contain the API endpoint, and I will demonstrate you to how it works. This when we use the slash data, we'll get the list of the data that collected from the sensor, and we can also here we can also provide the latitude and longitude, and it will show the information about the weather that we using API from the Open Weather API. And we can also predict the crop type, which it required to provide the humidity and moisture. See, it will give you the predict crop.